Hi all, Dr. Clark here again. Natural resources today, we're going to talk about oil. So remember we're on the subject of non-renewable resources. We've already talked about coal. We're going to talk about oil today, and then in later lectures we'll talk about natural gas and nuclear energy. Okay, so first I just want to show a little bit about kind of the United States, because that's where the majority of the people watching this are going to be from. Um, if you look at the amount or the percent of oil barrels, or oil in general, that we obtain from other countries, it's drastically increased since really, you know, since the 1950s, actually. So in 1950, we were getting about 8.4% of our oil from other countries. And then today, we really broke the 50% mark in kind of 2000, 1999. We're getting more than 50%. And today, it's closer to 62% in 2018. So the reason why I bring this up is there are lots of comments about drilling more oil and drilling oil at home in the United States and having less of a connection to the world industry of oil, but we don't have enough. Right? The estimates in 2010, this has been 8 years ago, was that the biggest oil fields that we have in the United States, which are in Texas, have about 5 billion barrels of oil left. Well, the world spends about 7 billion barrels of oil every year. So if we only have 5 billion or so left in Texas, which is our biggest storage of oil, we're not going to be able to break away from other countries. We need their oil, and you can see that we utilize a heavy amount of their oil and have so for a long time. Okay, so let's look at oil uses and the benefits of oil versus things like coal. Okay, so again, these are non-renewable resources, so we're going to use them faster. We're going to use the reserves faster than they could ever create. But that being said, oil is much more concentrated than coal, like I was talking about before, so the transportation aspect is much easier. Okay, so it can be transported in tankers, it can be transported in pipelines, and so the concentration is easier. It's an easier substance to move. It burns cleaner than coal does, and so it's releasing less of those things like mercury and sulfur and things like that to the atmosphere. That's not to say that oil does not release sulfur and carbon dioxide to the atmosphere. It does, but not as much as coal. Okay, so the compatibility, the movement, and the overall qualities of oil make it, at least as of a non-renewable resource, an ideal resource for automobile use. And we know this because majority of the vehicles in the world, vast majority, run off of oil. Okay? The problem that we have is oil is kind of difficult to find. Sometimes it is extremely deep in the, through the bedrock, and it's hard to get to. Other times, there's regions that you would think it was there, but it never formed there. And we just don't have good sources of oil. We have far more, when it comes to non-renewable resource. Coal far outweighs, there's way more coal in the world than there is oil. The other piece of oil is, for the most part, it is less environmentally damaging when removed than, say, removal of coal. Okay, the transport could be more damaging, but overall, it's less of an environmental concern removing oil than it is an environmental concern of coal industry or coal mining. All right, so how does this work? And I'm going to show you a video that goes through kind of the refinery process and how it's separated um, for the different types of oil: heavy oils, diesel fuels, gasoline, and these other fuel types. I'm gonna show you a little video on how they're separated. They're separated by evaporation and then condensing that material. But before that, how is it extracted out of the ground? So once it's been located, then the material is going to go through a couple different methods. Okay? The primary recovery method is by far the best, and this is the one that most oil companies are after. And that is, you drill through the bedrock until you hit oil, and then the pressure from the gas and the water associated with the oil is enough to force the oil out through the hole that was drilled. This is an excellent method in the sense that you're not expending energy, except for the drilling mechanism. You're not expending more energy to get that oil out of the ground. The problem is, often it doesn't last very long. So often after you've pumped some of the oil out of the ground through pressure method, and I shouldn't say pumped, after the pressure method has shot oil out of the ground, that water and gas pressure becomes too low, and the oil then has to be pumped to the surface. It's pumped through the surface by what we normally think of as what's sometimes called nodding donkeys. So it's a paddle that moves up and down. General term for them are nodding donkeys, but these wellheads or pumps, okay, work in a wheel fashion to pump the oil to the surface, okay, as the water and gas pressure gets too low. Okay, about 5 to 30%, depending on what type of rock you drilled through, how much water is in there, how much natural gas is in there, where, how deep was it. All these things really depend or are determining factors for how much oil can be just pumped out of the ground using a nodding donkey. The second recovery method is to have your main well. Okay, so you drill down into the oil, and then you drill two, sometimes more than two, separate wells, and you chase that oil up through the main well by pushing stuff down through the separate wells. Normally water is pushed down, but sometimes gas is pumped into the wells on the side, and I'll show you kind of a diagram of this, but it's pumped down, and that creates enough pressure to shoot the oil up through the main well. Okay, about 40% or so of oil is extracted this way. The tertiary recovery is when steam is pumped directly down the well, which lowers the viscosity and lowers the stickiness of the oil. So it really starts that kind of thermal property or evaporative property of the oil. And once it's become less sticky, then it can be forced up. Sometimes secondary recovery and tertiary recovery are done at the exact same time. So you're pushing steam down the main stem and then pushing water or gas on the opposite wells or nearby wells to force that material up. Now, tertiary recovery is very expensive, and really we only see these kind of methods when there's kind of a shortage of oil. So I would argue that as time goes on and as we progress with our oil use, that you'll start to see tertiary recovery become more abundant than what it has been. When we've had shortage of oil in the past, when we've had wars and things like that, or been cut off from getting oil from other countries in the 70s and things like that, we had to use some tertiary recovery methods to kind of get at as much oil as we could out of some of our wells. All right, so the processing really comes after the oil's been out of the ground. It's not, I don't want to say it's not good for anything, but it's not really suitable for any uses that we know of right now. So it must be refined. And so it makes its way to a refinery, either via like transport ships, so big, oil refinery boats, or it can move through the pipelines. It can be carried in trucks. There's a lot of ways at which oil can make it to a refinery. But at the refinery, and like I said before, I'll show you a video of how a refinery works in just a second. But at the refinery, you're going to take that crude oil and you're going to separate it into different products. Okay? And there's lots of ways to do this. You can break carbon bonds, and that happens often. You got to cleave so some of the molecules in crude oil are going to be carbon rings, and the ring structure is not very efficient in the sense of like burning and separating molecules, breaking bonds. So you have to initially break that ring and have it reform into a long chain. Okay? And so this is one process that's often done to create gasoline. But at any rate, I'll show you the video. It's much easier to see in the video. It's an excellent video showing how the material is refined. All right, now, when we talk about oil spills always make news because they cause a massive amount of damage. But really, when it comes to the grand scheme of things, oil spills don't actually account for much of the oil that is polluting our ocean. So the actual spilling from a freight liner, or having an actual wellhead, if we were drilling in the water, spill and things like that, it's not actually that much from those two processes. We have a lot of other processes that increase the amount of oil to a much greater extent than, say, accidental spills and things. So most of the oil that we see from the refinery process, or from the oil spillage, I guess you could say, is from routine shipping operations. So it's not that the boat collided and spilled oil everywhere. It's just a little bit here, a little bit there, a little bit here, and that's where a lot of the oil that pollutes our oceans come from. So here you can see an offshore drilling rig. Again, like I said, this is not the major polluter now when they blow up, clearly, or if they haven't plugged, the one in the Gulf a few years ago wasn't plugged and it's just shooting oil into the ocean. Yeah, that's a fair amount of pollution, but most of it's not coming from these. Okay. Here I'm showing you that secondary recovery. Here's kind of what happens is, again, you have another well over here, and maybe another well over here. You might want to have on the back side, and you're injecting typically water into these, okay? And that's going into the underneath the impermeable rock layer. So it goes into this layer that's already got water, it's got oil, it's got natural gas, and then it's forcing the pressure of that oil to come out through another pipe. This is the pipe where you would be attaching material, a collection device, to collect the oil off of it. So here you can see the kind of methods that we use to transport most often. Again, tanker trucks can be used, but it's a little more rare. Well, for large amounts, it's a little more rare than you would see, say, tanker boats or long pipelines like the Trans-Alaska pipeline that runs many, many miles. Right? These are ways at which the oil can be moved for long periods of, many, many miles and get to different refineries. Okay? So this can be utilized to pull up to port refineries. Also, it can be pulled up to trucks and transported to a truck, and then the truck can move to a refinery. Most of the time, these tankers are moving to port refineries, though, versus saying trucking it off afterwards. So the one thing that I can say from an environmental issue, environmental science issue, is the amount of spills that we've had from, say, things like tankers has gone down drastically. Our boats are much better, and probably more than the boat itself, it's the navigation devices. With the invention, I guess, of GPS, global positioning systems, we now have a lot less tanker action, hitting things, smacking rocks, these kind of things. So you can see it's drastically decreased. From the 1970s, we were at, about 30 or so tankers per year would spill in the 70s. To 80s, you got about 10. 90s, a little less than 10, maybe 7. And now in the 2000s, we get 1 or 2, maybe 3 a year. So a lot less spill, and that's really good news from an environmental issue. Here again, back to the marine oil pollution. Okay, like I said before, most of it's not actually coming from the active drilling. Okay, that's about 3% of the pollution. The transport of oil is about 12%, but a lot of that excess oil that's coming into the system is from consumption activities. So different boats, cars that are leaking material into streams, and that makes it into the ocean. This kind of stuff is about 38% of all the pollution, oil pollution, that's coming in. Now, you're not going to get rid of this piece. This is the natural seepage. This is the material that's naturally coming from the environment, is about 47%. So man-made stuff, we're looking about 53% of all the pollution oil that's coming into the ocean is due to man-made activities. The other 47% is coming from kind of native natural seepage, which, like I said before, you really can't do anything about this. This is natural for some of that oil to be seeping out into the ocean. All right, so now we're going to watch that little video about refineries and how oil is refined, to try to get at, when you go to fill up at a gas station, you now know, well, what's at least a little bit of the process behind making that gasoline or diesel, depending on the vehicle you're driving, making it useful for you as a consumer.
From the outside, an oil refinery looks like a small city. A city composed of pipes, tanks, and towers. But if you went inside, you might be surprised to find one of the most technologically advanced industries in the United States. Here, engineers and scientists have figured out how to turn raw crude oil into the valuable fuels, lubricants, and components we need to make millions of products. Refining begins with a process called distilling. After oil is superheated, it becomes vapor. The vapor is fed into the distillation unit. As it rises and cools, the vapor turns back into a liquid. Using stacks of trays, the liquid is easily collected and separated by weight. The lighter and medium weight liquids require less processing before they're ready to be used in cars and trucks. The heavier liquids need more processing to become useful. A process called cracking is used to maximize the usefulness of heavy oil. Heavy oil has long strings of carbon and hydrogen molecules. Using a catalyst, these molecules can be broken into smaller chains, transforming the heavy oil into lighter, more valuable fluids. Reforming is a process that increases the amount of gasoline produced from crude oil. One of the products separated in the distilling process is a liquid called naphtha. The number of carbon atoms in naphtha is about the same as the number found in gasoline, but their structure is more complex. Reforming rearranges the naphtha molecule, turning it into a usable, gasoline-like molecule. Blending is a process of mixing different refinery products to make finished petroleum fuels. Gasoline, for example, is blended to achieve octane standards, creating the grades of gasoline you see at the pump: regular, mid-grade, and premium, that are necessary to meet the needs of specific engine types. Treating is a process used to produce cleaner gasoline, which helps protect both the environment and our health. Gasoline molecules contain impurities like sulfur that can be removed. When the molecules are heated and come in contact with a special catalyst, a chemical reaction occurs that strips the sulfur away. These sulfur compounds are used as fertilizers and in pharmaceuticals. Nothing goes to waste in a refinery. In fact, by expanding existing refineries and improving their efficiency, we've increased production of refined products by more than 40% since the 1970s. So the next time you drive by a refinery, think about the scientists and engineers who are helping to efficiently transform raw crude oil into the fuels and products we use every day. Their innovative work helps keep prices low for the many things we use in our daily lives. And think about how refining, like other types of manufacturing, supports entire communities. Put it all together, and you'll see how refineries keep America moving.
Okay, so there you can see how a refinery works, at least on kind of the surface, not getting into much of the chemistry. When they talk about enzymes or specialized enzymes, really all it is a protein that can cleave a bond between carbon molecules. In doing so, you can break these carbon molecules up into smaller sequences, but you can also recombine them using other enzymes to make them more useful products for us. And so when you refine things to make other types of products, not fuel related, but other products like plastics and things like that, you do the similar kind of method that you would use, except for use a different kind of restriction enzyme or a different enzyme to break bonds and reform bonds and things like that. So pretty simplistic, but you can see as science gets involved, the amount of the refining process, the amount of material that we use, the pollution, that kind of stuff goes down, hopefully, and we can make what we have on the planet last longer. And that's kind of the overarching argument for spending money on existing refineries and updating those refineries is if we can do that, then maybe we won't be at a shortage of oil in the next 10 years. Maybe it'll be in the next 20 years or 30 years. It's coming. I assure you that probably within your lifetime, in the next 50 years, we'll definitely have a shortage of oil on this planet unless things have drastically changed. Because we know most of the resources. We know most of the reserves for oil. We know where it's at. And some of them we haven't drilled because they're not economically valuable. Others we haven't drilled because maybe there's a national park there. These different things, in 50 years we won't have an option unless things have changed. we will have to drill in national parks, and we will have to do all kinds of offshore drilling, and probably have to advance our technology quite a bit, because there are oil sources that are much deeper than we currently can get, and we might have to devise other technology to draw the oil out of those pockets. And we've been advancing our technology not just in refineries this way, but also in drilling techniques and things like that, by drilling diagonal drills and things like that, so you can get under layers, versus straight through a bedrock, these kind of things, which helps with the process tremendously. It's more economical. It's better for the environment many times, and better for the economy. But nonetheless, we will experience a shortage of crude oil, probably in your lifetime. And so we need to talk about ways in which we can alter this or change this, hopefully, to combat this in the future. And we'll talk about that in later lectures. Okay, with that, next time I lecture, we will talk about natural gas, and then we'll talk about nuclear energy.